We are presenting Chapter 4, Web Services from Web Scalability for Startup Engineers. I'm Abroy Chowdhury and my two teammates are Pritom, Shekhar, Shil. Pranto Chandra will continue of part 3. This chapter introduces web services, the backbone of distributed systems. We'll explore what they are, how they evolve, their design models, types, and scalability principles. To simplify, think of a restaurant analogy. The client is the customer here, the server is the kitchen, and the API is wait. It carries requests and responses between them. That's exactly how web services connect applications. When your mobile app asks for weather data, it doesn't talk to the weather database directly. It uses a web API that delivers structurally. This separation increases flexibility and reusability. Web service provides reusability, integration, and scalability. However, abstraction adds complexity, so smart trade-offs are key. Originally, web applications were monolithic. Everything was in one big problem. As systems grew and mobile apps emerged, APIs became necessary to expose business logic to multiple clients. In this model, APIs are added on a top of a single large web. For example, a hotel booking site that later opens data for partners. It's fast to develop but leads to tight coupling and poor scalability. This diagram shows a single application serving web, mobile, and partner clients. All share the same code base, meaning any change impacts the whole systems. This is efficient early on but hard to evolve later. The API first model flips the order. You design the API contract first. Every client from mobile apps to web portals uses that API. It's structured and scalable but requires careful planning of fleet. Then, all clients can communicate with a central API layer that contains the business logic. This ensures consistency and reuse, but designing such APIs early requires mature understanding of use cases. In practice, a hybrid or programmatic approach works best. Start small with a monolithic prototype for quick learning, then shift toward an API-first model as your product stabilizes. This balances speed versus structure, crucial for testers. Now, Ant will explain the rest. Thank you.
Hi there, I am Pranto Chandra and I am explaining some topic from Chapter 4 Web Services of Web Scalability for Startup Engineers book. Architectural types of web services. Let's explore the two main types of web services, function-centric and resource-centric. Function-centric models include SOAP and XML RPC, while resource-centric models follow REST principles. Function-centric services. SOAP-based services depend on structured XML definitions and WSDL contracts. They are powerful for enterprise because of strict standards and security. However, they are complex, slower, and don't support HTTP caching, so they are rarely ideal for startups. Resource-centric services. RESTful services are simpler. They use HTTP methods like GET, POST, PUT, DELETE, and exchange JSON instead of XML. They are stateless, easy to cache, and highly scalable, but lack strict contracts or auto-discovery. Keeping services stateless. Scalability begins with statelessness. Web service machines shouldn't store sessions or user data. That information should live in shared caches or databases. This allows load balancing, zero downtime updates, and easy auto scaling. Caching service responses. Caching improves response speed. GET requests can be cached through reverse processes like Varnish and Nginx. For authenticated data, use the vary authorization header to maintain privacy. Caching reduces database load and boosts scalability. Functional partitioning. As system grows, we split functionality into smaller, independent web services. For example, a product catalog service and a user profile service each can scale or evolve independently using its own data store. However, over-partitioning can cause complex integrations. Handling state, logs, and transactions. In large-scale systems, managing shared state becomes tricky. Avoid using logs. They slow down services and reduce availability. Instead of distributed transactions, use compensating transactions, where failed actions are rolled back asynchronously. This approach maintains consistency without blocking the system. Best practices. Some best practices for scalable web services include keep service stateless, design clear API boundaries, cache GET request aggressively, use functional partitioning wisely, and always balance simplicity and scalability. Summary. To summarize, web services bring structure and scalability to modern systems. Your architecture choice, monolithic, API first, or hybrid, depends on your team's maturity and needs. Scalability comes from stateless design, caching, and modular services. Thank you all for listening.